Hi guys, welcome to this video on surface area of a cone. Now this surface area formula that we'll develop and have a look at is a little unusual because we've got like a curved part and we also have a special type of base on this cone. Okay, so let's just have a look at how this formula has been developed. So let's just start off with a normal looking cone. So we've got like a curvy part on the top and then we end up having a circular base. So let's kind of visualize what happens when you kind of cut that and look at the net of this particular cone. So if you've got a pair of scissors and you cut along that specific line and unravel it, this is what you'll get. If you cut down here and you get 2 points, A and B, they are separated. There's your A, here's your B. This circular base, here's just your circle. That part is the slant height of the cone, which will be those two lengths. We'll call the slant height L. So the arc AB, this distance, is from a sector. So that arc AB is whatever the angle is, divided by 360, that fraction multiplied by 2 pi r. And our radius is L, so 2 pi L. But this particular arc goes around that circle. And that circle has a distance around the outside, the circumference, 2 pi r. So this arc and that arc, which are the same thing, have two different expressions. So that means that those two expressions are equal. So then we got the left-hand side equaling the right-hand side. We can divide both sides by 2, divide both sides by pi, and once we get that, divide by L, so L will go underneath the R. So theta over 360 is in the same ratio as R to L. So R over L is equal to the fraction. We're going to use this a little bit later on, so let's just look at what the area of these two are. So the area of this, which is the surface area, is going to be the area of that circle plus the area of a sector. Area of a circle is pi r squared. Area of the sector is pi r squared multiplied by the fraction. Now we're going to look at this theta over 360 and substitute r over L into that particular part here. So instead of theta over 360, it will be r over L. Okay, then one of those L's cancels with one of those L's there, and we end up having pi r squared plus pi r L. R is the radius, L is the slant height, so therefore this part gives us the base, this part gives us the curved surface. Okay, so that's a proof of the surface area of a cone. If the question said, let's find the surface area without the base, or it could be the top, without the circular part, we look at pi RL. If we look at both parts, we need both of these parts. Okay, I'm sure some of you have seen a drumstick or a cornetto before, and then they've got a cardboard wrapping around the outside. Sometimes they have a plastic part on the top. So what we're going to do in this question is look at the area of cardboard needed to wrap the ice cream, which goes around. We're going to ignore the piece of material that goes on the top. Sometimes that is cardboard, yes, that's fine. But for this question, we just want to find out how much cardboard will go around that ice cream. So we need to work out what the radius is, and we also need to look at that as our slant height. Okay, so surface area equals pi RL, which equals pi times radius times the slant height. In exact terms, that's 48 lots of pi, so 48 pi. And if we're going to do it to 2 decimal places, get your calculator, type in 48 times pi, or you could just type out that particular expression. And to the nearest 2 decimal places, it's 150.80. So that would work out the cardboard needed around that particular ice cream. Like I said, sometimes they put a cardboard top, sometimes they put a plastic. Just for the sake of this question, we're just going to find out how much cardboard is needed. So we need an area of 150.80 square centimetres to go around that ice cream. Okay, I would pause the video and see if you can answer the surface area for this cone where we need the circular base and also the curved surface. Let's round our answer to 1 decimal place. Okay, let's see how we go. We have the slant height, which is not given to us. So the slant height is either that section, that distance, or that distance there. We know the vertical or the perpendicular height, which is 30 centimetres, and then that's 10 centimetres. Slant height is what we're trying to find out. Again, Pythagoras' theorem comes very, very much in handy when we're working out the slant height. So looking at Pythagoras' theorem, and I'm going to leave it in exact terms, 10 root 10, or the square root of 1,000. So we don't round off too soon, otherwise our final answer is a little off. So leave our answer for the slant height in exact terms, and then we're going to use that for our calculation. So surface area is pi r squared plus pi rl, radius being 10, slant height being now square root of 1,000, or 10 root 10. So pi times 10 squared plus pi times radius times our slant height. You could use your calculator to evaluate that straight away, but I'm going to just go one more step and look at our exact terms. That's 100 lots of pi. This is 100 root 10 lots of pi. So then I'll just type that into the calculator and round it to 1 decimal place. So to 1 decimal place, we got 1,307.6 square centimetres. So that works out how much space is needed on the circular base plus, so circular base plus the amount of space around, which is a curved surface. Pi rl, curved surface. Pi r squared, area of a circle. Alright, pause the video again. Have a go at answering these two. One's given to you with the slant height, the other one is perpendicular height. And then see how we go and check to see if you got the answers. So the solutions, all the answers to this, here's 351.9 square meters, and for this last one, 703.7 square centimeters. Alright guys, thanks for watching the video on surface area of a cone. Hope you learned how to find the surface area of the curved surface, the circle, and the whole thing, the whole cone. So, thanks for watching.